drifting through a memory. Wake up in your crystal sky, floating till we fly.
Drifting through a memory. Hello, everyone. We are back on our day two of the Alien Week. And this time we are starting with another amazing session by Dr. David. And he's from NASA and he is going to talk about aliens, but in a very, very different way, in a way we might have never learned about. And you can ask your questions after the presentation is over. So start asking your questions in the YouTube chat and also listen to all the information that Dr. David is sharing in the beginning. We will take all the questions. So write your questions in the chat now, as we have about half an hour of time. So we are going to use it to learn all about the different types of life. Maybe we have life beyond Earth, life on Earth, and what does it all mean? So, Dr. David, we are so happy to have you here, and you may begin.
Thank you. It's such a pleasure to be with you all. Good evening, everyone. I'm looking forward to answering your questions as best I can. I may not have answers to all of the questions, and that's what makes science fun, of course. Should I go ahead and share a few slides? Is that okay?
Yes,
to get started.
Definitely.
Okay, let's try that again. And please tell me if it comes up in the wrong mode. Do you see the full screen mode or, well, let's see, not yet. Are you seeing full screen or presenter?
Yeah, we're seeing full screen.
Terrific, thank you. So I would like to introduce this idea of what is a scientist's job. A scientist's job is to solve mysteries, and we do that by collecting pieces of a puzzle. And we put those pieces together until they tell us a story. And in the case of aliens, the question that scientists are trying to answer is, are we alone in the universe? Not just that there are other human beings in the universe, but that there are other living things in the universe, and maybe they're different from our familiar life forms, but they could still be living things. And we would like to know if they are elsewhere in the universe. So we can, we start by asking questions. So we think about, what makes a good mystery?
To see if anybody.
A good mystery is something that's not easy to solve, and it keeps you on the edge of your seat. And certainly the question of, are we alone in the universe, keeps you on the edge of your seat. So let's think about this a little bit. Are we alone? What puzzle pieces should we collect to answer a question like that? And how can we collect those puzzle pieces? In science, we call this designing an experiment. So we design different experiments to go after different puzzle pieces. And we put those pieces together until they tell a story. So one of the things we can do is to visit other planets in our solar system. And we've sent many space missions to Mars because Mars looks like an interesting place where maybe life used to live in the past. So we go there with sophisticated instruments, and maybe in the not very distant future, we'll send people there and they will explore Mars directly. So Mars is interesting. We've learned a lot of things from our past missions to Mars, and we've gathered puzzle pieces. So we know a few things about Mars. Mars used to have running water on its surface, liquid water. Mars is very cold and windy today, and most of its air is carbon dioxide, which is not so good for our kind of life, maybe not so bad for plants. But it was a warmer place in the past, and it had a denser atmosphere in the past. When I say in the past, I mean about 3 billion years ago, so a long time in the past. And we've also learned that we can look for life where there used to be a lake, and we're doing that now. We're exploring a lake with the Mars Perseverance rover. You might have heard about that mission. And Another thing we can do to find additional puzzle pieces is that Mars and the planets and moons in our own solar system are not the only places we can look. We can look deeper into the universe. We know that the universe has just tons and tons of stars, and most of those stars seem to have planets. We've learned that too. That's another puzzle piece. And some of those planets are at the right distances from their stars, so they're not too hot and not too cold. They might be the right kinds of places for life to exist. So we can look around those other stars and look at their planets and see if we can learn some interesting things about them. So those would become new puzzle pieces. So these are some of the questions that we would like to have answers to. Do other stars like the sun have planets? We know that. Are any of those planets like Earth, and could any of those planets support life? And are there signs of life on those planets? What kind of life? So we already do have the answers to a couple of these questions. As I mentioned, we know that there are many other stars like the sun, and many of those stars have planets orbiting them. And we've already found a few of those planets that seem to be a little bit like the Earth. We know the Earth is a good place for life to live. We live here. So many other planets found already, more than 4,000 of them found around other stars. And a few of those planets are rocky planets like Earth, not just big balls of gas, but places where you can stand on a surface and water can be in oceans and seas. And in the future, we'll have better telescopes that we can use to look more carefully at some of these distant planets and learn about what's there and learn how many of those planets might be like the Earth. So here are a couple of questions that you might think about, and I'm sure you have plenty of questions of your own. So here are two that I might suggest to you. Besides visiting planets in our own solar system, and using telescopes to look at faraway places, how else could we look for life in the universe? Can you imagine how else we might know if there's life somewhere else? And another question, what will people think when you announce your discovery of life on another planet? How do you think your fellow citizens of the Earth will react when you say, I found life somewhere else? That's a pretty exciting possibility, isn't it? So my final message to you is never stop asking questions and always look for evidence. And that is an important part of this search for aliens. So you can think about aliens in a very speculative way. You might say, oh, well, I imagine an alien looks like this and blah, blah, blah. But what I want you to think about is evidence. So how would you design experiments? How would you look for puzzle pieces? And what actual evidence might you be able to bring to the puzzle and help to solve this problem of, are we alone? So with that, I think I will stop sharing my slides, if that's okay.
Yes.
And I will do my best to answer your questions.
That was a wonderful presentation, Dr. David, and the way you have described like this search for any other life form beyond the Earth, to see it as in a piece of puzzle, because the kids, the young students relate a lot to the puzzles. They relate puzzles to their everyday life and games. And imagine a scientist's job is also like just solving puzzles. And that's a beautiful analogy right over there. So let me just quickly see what other questions we have. So the very first question we have is regarding Mars. Like, why exactly is this the planet colored in red color? Is it anything to do with aliens, or Mars just happens to be red?
That's a very interesting question. It has nothing to do with aliens as far as we know, but it's not just by accident either. Mars has its red color for the same reason that rust is red when iron rusts. So there's iron in the soil of Mars, and it was exposed to oxygen and it rusted, and that turns the whole planet's surface to red.
Yes, so it's not aliens, but yes, we understand the science behind it. Another question is, how do we measure the universe?
Oh, in so many ways. So I showed examples very quickly of two ways. One is that we can go to some places and visit them. So we can go to planets and moons in our own solar system. So visiting Mars is possible. Right now, we visit Mars with spacecraft that land on the surface, and some of them rove around. We even have a little flying helicopter that flies around on Mars. So these are some of the ways that we can explore parts of the universe that are still pretty close to us in our own solar system. But many parts, as soon as you leave our solar system, it's a very long distance till you get to the next one and the next one and the next one. But there are literally hundreds of billions of other places like that in the universe. They're very far away, and we can't even imagine how we could possibly visit them directly, but we can observe them with telescopes. And so telescopes come in many, many different types. When you're stuck with having to observe things at a distance, you want to take advantage of every possible tool you have to do that. So the universe sends us signals in the form of light, and it sends us signals in the form of other things that we're just beginning to explore now, like gravitational waves. But most of what we think about comes to us in the form of light. And light comes in many, many colors. There are all the colors of the rainbow that our eyes can see. But even beyond the rainbow colors, if you go farther than red, you get to infrared, and farther than infrared is radio wavelength. All of this is light. If you go shorter than blue, you get to violet and ultraviolet, and then eventually X-rays and gamma rays. So we have telescopes that are designed to make measurements of all of these different kinds of light. And we learn different things about the universe by using the different telescopes, and those are all puzzle pieces. We put those pieces together. So in addition to visiting the relatively nearby places, we also observe the very distant places and gather their signals.
And we have a question by student Bhavya Joshi, who's asking, why is Venus called Earth's twin?
Interesting. I think it is because of a couple of things. It's the closest planet to Earth. It's even closer than Mars. It has an atmosphere like the Earth has an atmosphere. It's actually a very, very dense atmosphere. And it's possible that in the very distant past, both the Earth and Venus were a little bit more similar to each other than they are today. They're not very similar. Venus still has a very dense atmosphere, much denser, I think, than ours, but it's extremely hot. It's much closer to the sun than the Earth, but that's not the only factor. The dense atmosphere traps the sun's light and keeps the planet roasty toasty, hotter than an oven. So today they're not very much like twins, but in the distant past they were more like twins.
Yes, so even though they're different now, because of science and studying a planet, we can learn so much about its future, its past. And we have one more question, again by Bhavya, who's asking, can we take the sample of Mars and research about it to find if life is possible there?
Absolutely. That's a really interesting question. One of the things that the Perseverance rover is doing right now on Mars is gathering samples which a future mission to Mars will go and retrieve and bring back to Earth for study. So all of the past missions to Mars are stuck there on Mars, and they do whatever experiments and information gathering, the evidence, and the puzzle pieces, they have to do that on Mars. But in the future, we're going to grab some of these samples and bring them back and study them in our own labs, the way we've already been able to do with samples from the moon. And we're going to do some more of that as well. But Mars seems to be a much more interesting place for life. So
Yes.
that will be exciting.
Yes, excellent question. And Vinita is asking, is it possible for alien life forms to be more developed than us? If yes, then how?
Well, it's certainly possible. And I would say maybe even likely, but there you're getting out of the realm of science and more into the area of speculation. But it's still interesting to speculate about this. So when I think about a question like that, what I think is that there are all of these hundreds and hundreds of billions of other places where life could exist in the universe, on other planets. And the universe is now about 13.7 billion years old. We know that life on Earth, the Earth is about 4.5 billion years old, and life on Earth got started when the Earth was still pretty young, which suggests it doesn't take very long for life to get started. Now, of course, it took almost 4.5 billion years before we had relatively intelligent life, before there were mammals, and then before there were people and other intelligent creatures on the Earth. But, you know, there's 4.5 billion years for intelligent things to happen, but the universe is 13.7 billion years old, and there are many, many other places. So I think it's entirely reasonable to think that there could be places where there are many more sophisticated and even more intelligent beings than we are.
Yes. And Estrago is asking, what about Area 51? Is that a puzzle too?
Could you repeat that? I didn't quite hear it.
Yes, Area 51.
Still didn't come through clearly. I'm very sorry.
Yes, they're asking about the place on Earth, Area 51, if you have heard about it, because that is associated with aliens.
Oh, maybe I haven't heard about it, or maybe I'm just not quite understanding the name. Can you spell it for me, the name of the place?
Yes, it is AREA F51.
Oh, Area 51. Yes, sure.
Yeah.
I've heard about this. I don't know anything very much about it, except that it has a reputation for being a place where maybe aliens landed. But because I don't really know anything, I don't have evidence. And without evidence, I can't comment. I just don't know.
And one student is asking, as you said that there is so much carbon dioxide on Mars, so can we plant a plant so that there we have a little bit of oxygen?
Yes, I think that would be possible. I think there's even a name for that. I think it's called terraforming, to try to turn Mars into a planet more like the Earth, with an atmosphere that would be breathable by humans. I think it would probably take a very long time before that would happen, but I think it's possible. And I have read recently that someone did an experiment where they took a little bit of soil from the moon and used that to grow some plants. Well, the moon soil is probably different from Martian soil, but you can imagine doing the same kind of thing on Mars and growing plants on Mars, and eventually they'll produce more oxygen in the atmosphere, and maybe it will become breathable. You'd have to worry about the density of the atmosphere too. The air is very thin on Mars. Mars lost most of its past atmosphere. It just evaporated into space. So it's not only a matter of having the right things in the atmosphere, the right chemistry in the atmosphere, but you also have to have enough air to breathe. So
Yes.
it's a long way from that right now.
Yes. But yeah, I'm seeing some wonderful questions more. I had one question. So which astrobiology mission are you most excited about? Because NASA is planning quite like handful of missions which are in the field of astrobiology, which was not so popular back, I would say, a decade or two ago. But now we have such dedicated astrobiology missions which are looking for signals. So is there any mission you are very excited to see the launch of?
Oh, goodness. I think I'm excited about everything we ever launch because everyone brings back puzzle pieces. But in terms of astrobiology missions, um, I can name a few. I can't name a single one that I'm most excited about. So I will say that returning samples from Mars will be very exciting. And that's only, I don't know, a few years away, not in the very distant future. We're designing that mission now. There are future telescope missions planned. So rather than visiting a place, we're looking farther away. One of those is designed to look for Earth-like planets. And that's a visible wavelength and ultraviolet telescope that is large enough that it has very good imaging resolution. And so even though you're looking for a tiny little planet next to a very bright star, and they're pretty close together in space, that telescope would have the ability to distinguish the planet's light from the star's light, and say whether that planet is Earth-like. That's maybe another 15 years away or 20 years. It'll be a while, but in the lifetime of all of us here, we hope. And missions that I'm more involved in work at longer wavelengths in the infrared part of the spectrum. And we can do some special things in the infrared having to do with probing the chemistry in certain places. So one of the things that we can think about is we call them bioindicators, indicators that there could be life somewhere, but there's also a word that we use called biosignature, which is like a direct signature that there is life somewhere. So a biosignature is a really important thing to find in the atmosphere of a distant planet. And you can do that in infrared light. And what you look for is a planet whose atmosphere has chemistry in it that would not be there if it were not for life. The chemicals would react together naturally just through chemical reactions and destroy each other. But if you find them there, then that indicates that life is replenishing those ingredients. That's the kind of mission that I would really like to see happen. And that's probably also 15 years away or so.
Yes, so a lot of these missions, as you are suggesting, are going to take maybe another decade or two. But I hope when the kids are, because right now they are just in middle school, when they grow up, when they are in college or they are beginning their own research, all these projects will be live and they will be able to use the data from these projects and ask even more bigger questions, which we think are impossible now. Yes.
That is absolutely right.
Yes. So, Dr. David, do you have any books or any suggestions for these students that what can they go and do? Like something, any advice for the students who are really interested in this field of astronomy, astrophysics from such a young age?
Oh, goodness. There's so many books. And so many different, I think the age range of your audience is pretty broad, right? So I can't name a single book. I would say for the older students in your audience this evening, one that I read last summer, I found spectacularly good and very nicely written, it's about the topic of thermodynamics, which sounds like a big, complicated word. Thermodynamics is everywhere, and it does affect all sorts of things about how the universe works, including how life can get started. And this book is a mixture of how both the science and the history of how thermodynamics developed. It's called Einstein's Refrigerator. And the title itself is kind of curious because we don't think of Einstein with refrigerators, but it turns out that he actually had invented a concept for what could have been the first refrigerator. And that's a thermodynamics kind of thing. So I do recommend that book, Einstein's Refrigerator. But for younger members of the audience, there are just so many wonderful stories about the planets in our solar system, and the whole universe. I would say just go to a library, find that bunch of books on the bookshelf there, and pick out anything that you're curious about. I'm sure you'll learn something. When I was very, very young, I had an interest in astronomy from the time I was certainly 8 years old, if not earlier. I think I still have on the bookshelf behind me some of my children's books. But of course, we've learned so many new things since that time. So you'll really want to explore the newer things that we've learned. Another thing that I used to do as a child was to write letters to NASA. And of course, NASA is not a person, it's many people, but you could write, "Dear NASA, I'm interested in something," and I would hear back from whoever it was. They would send me, 8x10 glossy images of planets and things that we were sending into space probes and things like that. I was very curious, and I'm sure that the children joining us today are very curious. And imagine how you can gather evidence. You can gather it from books, you can gather it from conversations like this, and speaking with people, and writing to people, and you'll just be astounded by what you might learn. And of course, the internet, that didn't exist when I was young, but it's there's tremendously good information that can be found that way. Look for NASA websites, something.nasa.gov, and you'll find many, many interesting things. You do have to be careful about knowing what's good evidence and knowing what you should be suspicious about, and that's part of asking good questions. So part of a scientist's job is to be skeptical, and if you see something that doesn't look right to you, maybe it's not. So be curious about the information you see, and only believe something if it really kind of makes sense.
That is wonderful advice. And all the students, the name of the book was Einstein's Refrigerator. And for other students, they can visit the website of NASA. So whatever you like, any new term you found, just write that term in Google and NASA, and whatever website you find, there is, I hope, some information there which is going to help, and your curiosity will be quenched. So Dr. David, I want to thank you so much for joining us today and being here on such a short notice and making our Alien Week 2022 even more lively. Thank you so much.
Thank you so much. It's a great pleasure to be here. I really appreciate the invitation, and
Yes.
Thank you. Have a very nice evening.
Yes, thank you. Bye-bye.
Bye.
call with us, and they know a lot about so many things. And they have also worked in the NASA. So, all the questions you have about life on Earth, life beyond Earth, or maybe what is NASA doing to find aliens? Any questions you have, Dr. Kaul is with us here today, and they are ready to answer your questions. So, we are so happy to have you, sir, first of all, here and for accepting our invitation on such a short notice.
My pleasure.
Yes. So the very first question we have over here is by student Sirat, who is asking, are there any more galaxy like our own Milky Way galaxy? And if yes, can we visit them?
Well, there certainly are many, many more galaxies. There are, 100 billion galaxies or 200 billion galaxies in the observable universe, so that there are lots of galaxies. But galaxies are so far away that the only way that we can visit them is with telescopes, because we can see the light that's coming from those galaxies with telescopes. So we're not sending spacecraft there, but we think that those galaxies have a lot of stars that are similar to stars in our own galaxy. And we know that most stars in our galaxy in the Milky Way have planets. And so it's reasonable to think that most stars in other galaxies also have planets. So the number of planets in all those galaxies is just uncountable. And the potential for life on at least some of those planets is really very, very exciting, both in this galaxy and in other galaxies.
Yes, definitely. And another question is by HK, who is asking, why does space does not have any gravity?
Well, gravity is actually a property of matter existing in space. When you go into orbit around the Earth, you don't actually escape the Earth's gravity. You're actually still in Earth's gravity. But what's happening is it's as if you're falling. Imagine that you were in an elevator and the cable on the elevator broke. Now, that's a really bad thing because that's not going to end well. But let's say you were in a really, really, really tall building. And while the elevator was falling, you in the elevator would be just fine. You'd be floating around inside the elevator because you in the elevator would be falling at the same speed. And it would seem as if there were no gravity. You would just start floating. Until, unfortunately, of course, the elevator reached the bottom of the elevator shaft, and then it wouldn't be a very good outcome. But that's what's happening when you go into space. You're actually falling through space in your spaceship at the same rate. And so it appears that that you're not being subjected to gravity, but actually you are.
Yes. So I hope that answer helps. And we have one more question. And a student is asking, is there any evidence of microbial alien, any kind of life detected on Mars?
There is not evidence yet of microbial life on Mars, but we think that microbial life on Mars is a very real possibility. And let me give a somewhat longer answer to this question, because this is one I think of the most interesting topics. So in order to understand the possibilities for life beyond Earth, be it on Mars or on Jupiter's moon Europa or on planets around other stars, we begin with studying life on Earth. And when we look at life on Earth, we see today life is very diverse on Earth. We have animals, we have plants, we have a variety of different kinds of animals. But we also have microbes. And when we look at the history of life on Earth, what we find is that for most of Earth's history, Earth is 4.5 billion years old. For most of that history of Earth, life on Earth was entirely microbial. So it was only microbes for the first 3.5 billion years of life on Earth. And so when we think about the possibility of life elsewhere, the very first thing we think about, as your questioner astutely noted, the very first thing we think about is the possibility of microbial life. So on Mars, we know today there are no animals walking around on Mars. We're pretty sure if there was a giraffe walking around on Mars, one of the cameras, either in orbit or on the surface, would have picked it up. So we know there are no animals walking around on Mars, but there could be microbes, particularly underground. If there ever was life on Mars, chances are it would have started off as microbes. And even though the surface of Mars today is not very hospitable to life, some of those microbes could have gone underground and survived, possibly even to the present day. So what we are now doing on Mars is exploring Mars, looking for either signs of ancient microbial life, microbes that aren't alive anymore, or possibly even what we call extant life that is alive on Mars today, most likely microbes below the surface.
Yes. And Bhavya is asking, do you think there is something like the parallel universe?
Do I think there is something like the parallel universe? I don't know, but I would love to know. Wouldn't that be exciting? Maybe there's another Rashmi and another Carl, and they're talking, and maybe they're having a different conversation. Who knows? Maybe their conversation's more interesting. It wouldn't be neat to tune in and find out?
Yes, yes. And the question has, the student has one more question. Can you try to send microbes to Mars to check if they can survive there?
That has been seriously proposed, and it would be a very interesting experiment. We can actually do that experiment on Earth because we have the ability on Earth to simulate Mars. So we have chambers in which we can put simulated Mars soil, because we've studied Mars soil and we know more or less what its composition is. So we can put simulated Mars soil into a chamber. We can put in basically gases that represent the Martian atmosphere, which we've also studied. We can adjust the temperature, we can adjust the light that's entering the chamber, and we can put microbes in those chambers, and we have done that. And I actually don't recall exactly the results of those experiments, but it's certainly possible to do the experiment and to see under what conditions microbes could grow. What we do know is that at the surface of Mars, the conditions are very, very harsh for microbes. And the thing that makes it particularly harsh is the ultraviolet light. So if you do the experiment that I just suggested and described, and you irradiate it with sunlight coming through a very thin Martian atmosphere, what we find is that the ultraviolet light will destroy microbes on the surface. The other thing that we know about Mars is that a lot of the surface soil has a strong oxidant in it. And that is a material kind of like hydrogen peroxide, which, as you know, is used as a disinfectant and will destroy microbes. And so that oxidant in the Martian soil also is very, very hostile to microbes. So microbes probably cannot exist right at the surface of Mars, but microbes could possibly exist underneath the surface of Mars, where they're protected from the light and possibly protected from the oxidant, which might be more near the surface. Now, there is another interesting question, though, that is raised, and that is, do we want to send microbes to Mars? Because one of the things we would really love to know is, are there any microbes that are already on Mars, that have been on Mars for the last 3.5 or 4 billion years, since the time when Mars was more hospitable toward life? And one concern is that if we were to send microbes to Mars, and if those microbes could survive on Mars, then the problem starts getting confusing, because then if we found microbes later on Mars, we'd have to ask, are these microbes that started on Mars, or are these microbes that we brought to Mars? In fact, we even have to worry about that when we send spacecraft to the surface of Mars. So one of the things that we want to do is make sure that we can't remove all microbes from spacecraft that we send to Mars, but we want to remove as many microbes as possible, because we want to minimize the possibility that we might transfer Earth life to Mars, and that Earth life could then persist on Mars, and we could discover it later, years from now, and think, oh, we have found Martian life. And it turns out it was just hitchhikers that came along with some of our spacecraft.
Yes, I think the students might not have heard or knew about that second possibility, that even though it sounds like such an exciting experiment idea, sending microbes from here on Earth to Mars, it can have certain complications. And one more question is, what is NASA doing in finding the evidence of aliens except the planet Mars? So are there any other places where NASA is hoping or searching the evidence?
Very, very, yes, absolutely. So one very interesting body in the solar system besides Mars is a moon of Jupiter called Europa. And Europa is very interesting because Europa is mostly made out of ice. Its density tells us that it's a mixture of about half rock and half ice. And we think that Europa has a fairly deep ocean, an ocean perhaps 100 kilometers deep, covered by at most a few kilometers of ice. And so one of the very interesting questions is, could there be life in that ocean? There are other worlds, other moons in the outer solar system that also have oceans. But Europa is particularly interesting because its ocean is relatively close to the surface. And there may be transfer of material between the surface and the ocean. And this makes it very interesting because it means that some of the ocean may be making it up to the surface. There may even occasionally be plumes of water that come out of the surface of Europa. We're not completely certain about that. So it may even be possible to study the surface, to study the ocean of Europa, not only remotely, but maybe even be able to sample bits of that ocean from a mission. And we have a mission called the Europa Clipper mission, which is going to be launched to Jupiter in a few years, which is going to go into orbit around Jupiter. And it's going to fly by Europa many, many times to study Europa, and particularly to see if we can learn more about Europa's ocean. But Europa isn't the only body in the outer solar system that has oceans. Another one that's very exciting is a much smaller moon than Europa. Europa is about the size of the planet Mercury. It's a small moon, or actually it's about the size of Earth's moon. But Enceladus, which is much smaller, is a moon of Saturn. And that is a moon where the ocean is spewing out into space. And we have been able to study the plumes of water coming out of the ocean. And there are organic materials in that water. There are salts in that water. It looks somewhat like the water that we have in some lakes on Earth that are called alkaline lakes. There's one here in California, not too far from where I live, called Mono Lake. And the water in Mono Lake is somewhat similar to the water that is coming out of Enceladus in the plumes. And so there is another ocean, it's a smaller ocean, that's underneath the surface of a moon in the outer solar system that is spewing material out into space. And we have proposals for missions to fly to Saturn and to go into orbit and to fly through those plumes as well. So yes, there are many other places that we can study to see if there's any evidence of life. Now, I
And
cannot hear you. Okay.
Yeah. And talking about lakes, Basil is asking, okay, the question was the Black Sea. So what is the Black Sea has this word black in it? That was the question.
I do not know the answer to that question. That's a very interesting question. I think I'm going to look it up after we get off this this session.
Yes.
I don't know that. I just don't know the answer to that question.
Yes. And they have asked another question, which is, do aliens use technology?
Well, this is a really, really interesting question. So obviously microbes are not likely to use technology. But the question that the student is really asking is, could there be more advanced aliens out there? Could there be aliens that have formed civilizations and developed technology? And the answer is certainly yes, there could be. Now, we have no evidence of such alien civilizations, but there are many people who think that surely in the vastness of the universe, there must be other civilizations of technological civilizations. And so there are many people who study what we call technosignatures. And technosignatures are evidence of exactly that, evidence of aliens that are capable of using technology. Now, we used to think that technosignatures, the only technosignatures we could study were radio signals, because after all, for many years, the main way that an alien civilization might have detected us on Earth was by our radio emissions, first from radio and then from television. But we also, of course, have radars, and radars, although they send out a very narrow beam, because that beam is narrow, it's actually much more powerful than our just general radio and television emissions. And once lasers were developed several decades ago, now here's another kind of signal that we can send out into space, and that would be detectable by an alien civilization. And similarly, if an alien civilization were using lasers as well as radio signals, we might potentially be able to detect them. But there's a technosignature study now goes beyond that, because one of the things we know is that through our technology, for better or for worse, we have altered the planet. Particularly, we have changed our planet's atmosphere. There are gases in our planet's atmospheres, chlorofluorocarbons, for example, that are manufactured gases. Those were manufactured as refrigerants, and they wouldn't exist in the atmosphere in the absence of our civilization and technology. And of course, we've changed our atmosphere in other ways through burning fossil fuels, etc. So there are various gases in our atmosphere that are either present in a different concentration or are present at all just because of our technology. And so one of the thoughts is, as we develop the ability to study the atmospheres of particularly planets around other stars, we can look at those atmospheres, not just look for radio signals or lasers coming from those planets, but actually look at their atmospheres and see if we can see any evidence of something that might be the result of technology on those planets. We're not there yet in terms of the capability, but it's a very, very interesting experiment to consider. And people are writing papers today about what kinds of things we might want to look for.
Yes, that definitely sounds very exciting. Thank you for asking that, Basil. And one more question is, what are dwarf planets?
What are dwarf planets? Well, there are how you define a planet has changed. over time. And probably the example that most people are most familiar with is the case of Pluto. So when I was going to school, when I was the age of the students who were asking questions, I knew that there were 9 planets in the solar system, and Pluto was the furthest most from the sun, the 9th planet. But then some people started thinking, well, there are all these asteroids, and we don't call these asteroids planets. And even when I was in school, we knew that there were hundreds or thousands of asteroids, and now we know that there are many, many more than that. And so the question became, so why is an asteroid not a planet, whereas Earth and Mercury and Jupiter are planets? And so people started to think about different ways of defining a planet. And one of the ways that it was thought to define a planet is that if a planet has enough of a gravitational field to clear out the area around its orbit. So the thought arose to define a planet in terms of its size, because, or more precisely, in terms of its mass. Because if it had enough mass to attract the debris in its orbit, and basically to either have that debris hit the planet or have that debris be scattered gravitationally away from the planet's orbit, then that is an object that had enough mass for us to call it a planet. And that led to the development of this category of object called dwarf planets. And Pluto was the first one in our solar system classified as a dwarf planet. And that is something that kind of looked like a planet, but it was too small to pass this new definition of a planet. And since then, we have discovered many other dwarf planets, particularly in the outer solar system, even out beyond Pluto. And so there's an argument that Pluto is just one of a category of objects that we now call dwarf planets, and they deserve to be distinguished from the more massive planets in the solar system.
Yes. And we have a few more questions, but looks like we are about near the time. So students who have more questions, we can share your questions to Dr. Karl. And I want to thank Dr. Karl for coming here and sharing all this knowledge and answering these questions patiently with another angle and analogy, so that the students are even more curious about science, space, and so much more. Thank you so much, Dr. Karl, for joining us today.
It has been my great pleasure, Rashmi. Thank you for inviting me. Take care, and best to you and to all the students.
Yes, thank you, sir.
Bye-bye.
Slowly falling through the night, illuminating coastlines, headlights toward the afterlife, bright enough to shine. Colors fade to the waves, swimming through reality. I see your eyes above it all. I can hear you call. Starlight raining over me, like drifting through a memory. Slowly falling through the night, illuminating coastlines, headlights toward the afterlife, bright enough to shine. Colors fade into the waves, swimming through reality. I see your eyes above it all. I can hear you call.
And glad to see you. First of all, I would like to thank the Kalam Labs and Rashmi for inviting me. And I would like to greet all the astrobiology enthusiasts, all of you who came here. So this is amazing that there are so many people interested in the mysteries of life and universe. And I specifically do something interesting in astrobiology. You've heard lots of scientists that study the universe, but I study how do we teach them to people, and this is a different piece of the puzzle, right? So I do astrobiology education. And I wonder, do you know how many people are doing astrobiology education around the globe? I just came from an international conference on astrobiology. It's called AppSciCon, Astrobiology Science Conference. It happens every 2 years, and scientists from all over the globe come there, but not just scientists, also educators. So what do these people do? And why do they do what they do? So if you wish, take a guess and share it in chat. So why do people consider it important to teach astrobiology to the kids of your age? And what exactly do they talk about with them? So let's take a minute, share
Yes.
your answers.
Yes. And it will also take a while because of the streaming lag.
Okay, so I'll give you a minute, no worries. So why do we think it is so important for people of your age to start considering astrobiology? And what is astrobiology? If you take a look at the word itself, you will see that astrobiology consists of 3 roots: astro, bio, and logi. Astra is about space, about the universe. Bio is about life. And logi is study and wonder and reflect. Astrobiology encompasses it all: life, universe, wonder. So, but of course, you've heard several presentations already on how we search for life on other planets, on exoplanets, how we search for the signals from other worlds. How do we search for life that is intelligent? What is intelligent life? What questions may we ask about intelligent life? Well, the first question is, of course, yes or no. Is there an intelligent life, right? If yes, where? How do we find it? How did it start? What if it's different from what we expect? How we think about intelligent life? How do we detect them? How can we contact them? Should we contact them? Lots of people are not so sure about that. How different are they from us if they're there? How similar is it? What drives those differences and similarities? What could drive those? Do they like honey? Are they afraid of spiders? Can I play chess with them? Can they smell the roses? Would they enjoy music? Do they even have ears? Do they even have noses? Are they big? Are they small? What kind of planets do they prefer? Do they live on the surface or in water or underground? Are they fast? Are they slow? We do know that there are many organisms on our very own planets that experience this world very different from us. Even here, it may be very different from creatures from other worlds. And how do we know that they're intelligent? How would you check if something that looks very different from you and has very different needs is intelligent? How about dolphins? Should we consider them intelligent? They live in families, they talk to each other, they help each other, they can solve problems together. They can learn when you call them, they have names that they use. How about elephants? Elephants are extremely smart, intelligent animals. They can listen to you, they can interpret your behavior, they can help each other, they care for each other. Where is that boundary where you say those organisms are intelligent and those organisms are not intelligent? How do you develop the intelligence scale? So you could see any creature that looks very different, an octopus, a spider, I don't know, a slime mold. How do you define whether they're intelligent or not? A slime mold can solve puzzles. You know, little yellow clumps of goo that live in the forest. They solve puzzles. So, if you were to send a message to extraterrestrials, what would you send them? The question how is also interesting, right? Would you use radio waves? Would you use lasers? Any other means? Would you put your letter on a flash drive or on a smartphone and send to them? But even more interesting is the question like, what do you want to send to them? What is important for you to share? And why is it important? And is it going to change over the time? Because as you grow, the things that were important for you before are not important anymore, and you get new things that are important to you. It is true for a human being. It is true for the whole civilization. The things that could be important for a civilization, for a young civilization, may be not that important for a more advanced civilization, and vice versa. Now, as you decide what to put on this message to extraterrestrials, who should decide it? Should you persuade other people? Should you collect their inputs? Would other people agree with you on what is important to share? How is it going to change over thousands of years, over millions of years, that may take your message to reach other civilizations. Maybe our civilization will be no more by the time our message reaches other civilizations. What kind of legacy do we want to leave? Some people say we should use mathematics to send messages to extraterrestrials. Well, mathematics is tricky. We don't know whether mathematics is discovered, so it is the same for all the creatures in the universe, or whether it is invented and it is specific just to us humans. Now, question to you. You all know arithmetics. Tell me whether 11 plus 3 can be equal to 2. I want you to tell me in chat whether it is possible. And if yes, in what situation? I'll give you a minute.
11 plus 3.
Can 11 plus 3 be equal to 2?
Come on, students, what do you think? Can it be equal? You can try to plus it and see if it is equal or not. Let's see.
So I can tell you something. There is a field of mathematics that is called modular mathematics. So if you look at the clock, at the face of the clock, and you see the hour arrow, right? You will see 11 hours, and then you add 3 hours, and you end up where? You get 2 hours, right?
Yes,
So
yes.
this is just one of the examples when people can use different types of approaches for mathematics, right? So, and we can probably with time figure out the alien mathematics, but it may take us really long time until we figure out the way they are thinking and what kind of problems they are trying to resolve. Now, let's say we're sending not the letters because we don't know our languages. We're not sending mathematics. Maybe we should use images, pictures. Well, now we're running into a problem, that a well-known problem for biologists, that living creatures here on Earth experience the Earth and see the world very differently. If you take a look at this nest that you see here, the human vision, you see it in brown. For birds, they look like red. If we compare the way a human sees a cat and a snake sees a cat, the snakes are using infrared vision. So the snake will see it completely differently. What if the extraterrestrials have a different type of vision from us? What if they have infrared? What if they have ultraviolet? What if they see much better than us? What if they see much worse than us? The same problem is applied to the sounds. We can hear only a certain range of sounds. We cannot hear really low sounds and really high sounds. Little moths can hear much higher sounds. Teenagers, human teenagers, kids and teenagers can hear the sounds that adults cannot hear. You right now can hear some of the sounds that I cannot hear anymore. So maybe those extraterrestrials may hear something that we don't hear and vice versa. How are we going to talk to them? How are we going to share images with them? What else can be different? They can smell things differently. Maybe what smells, good to us will be ugly and disgusting to them and vice versa, right? So how do you design a message in a ways they will understand. So people tried to do it in 1970s, for example. A space probe Voyager left the Earth carrying the golden record. The golden record is a golden disk, and if you rotate it at certain speed, you can get the images and get some information about our world. So I want to show you just a few images. From that record. Let me click. And I will make sure that I share. So these are the images that were put on the golden record. Now let's take a look at what people see here and how they can interpret. So for example, you and I, we all know that it is what? A violin, right? A violin and notes. However, if you are an extraterrestrial, you have never ever seen a violin before. You also never saw notes before. You don't know that violin is made out of wood. Maybe they have no wood on their planet. You have no idea whether this violin is big or small. And you have no idea how to play the violin. You have no idea what you are doing with this violin at all. Maybe you are looking at this picture and maybe they will say, it's a cookie and the recipe for the cookie. That's how you prepare it. Or maybe they will think, maybe it's like museum artifact, something very important for human beings, since they're sending it to us. Or maybe they won't be able to see it at all. Or maybe they will be able to see only part of it. So how would you design a message to extraterrestrials? One more picture maybe here. Let's see. So we see a woman here doing something with a microscope. But how do they know that this is a microscope? Maybe this is something connected to her eyes to send messages or to read your thoughts. And what is there on her ears? Maybe it's a Bluetooth. They don't know about earrings. Or maybe it's some type of an insect. Or maybe it is something else, right? So it is extremely difficult to interpret a picture without knowing the whole context of what the planet looks like, what do people do there, what is their culture, what is their level of technology. It is very, very difficult to craft a message like that. So let me switch back to my slides. So, and as we are trying to decide what to put on this type of a message to extraterrestrials, we really need to decide to learn more about ourselves. Interestingly enough, to learn about space, we need to start with ourselves. And we need to think about what do we, human beings, consider important for us. What do we care about? What are our priorities? What do we want to share with the outside world and to preserve for thousands and millions of years? So imagine that you are trying to explain to an extraterrestrial who have never ever been not only to Earth, but even to the solar system, what a human being is. What should you focus on? What is most important defining things about humans. I would give you another minute, and please try to share in chat.
Yes, definitely. The question that you had asked about the clocks and or the timing 11 plus 3. A lot of students said no for that. Let's see what do they say for this one.
This one is a deep scientific and philosophical question that I am asking you right now. It's not easy to answer it right away. You really need to give it some time.
Yes, students. So, what do you think? What is or who is a human? How can you define yourself?
Should you define it on a cellular level as a creature that lives on the surface of the planet and has 2 arms and 2 legs? What if you lose an arm? Are you not a human anymore? What if you're a child? Are you still a human? If you don't know mathematics, are you still a human? How do you define a human? And if you have a head, are you a human or a dog or a robot? How do you distinguish between a human and a robot? It's a tricky one. Can we make a robot, a biological robot, out of biological tissues? Can we grow a robot? Will we be able to grow a robot soon? And how would you define a human then? What would change? What if you genetically change a human being and make them in the dark? And we can make living things glow in the dark right now. For example, we can make cats that glow in the dark. We can add some genes from sea creatures that glow in the dark into the genome of a cat and make a cat glow in the dark. What if we make a human glow in the dark? Is it still a human? No? Yes? So I really want you to think deeply about what it means to be a human. Are we getting some answers there?
I'll have to see. I will have to see. They were asking, okay, yes. Bhavya says human is an organism which can make their own decision and can feel emotion.
Well, a squirrel can make its own decisions. A cat can do that too, and they do feel emotions. Do you agree? So, are we cats and squirrels?
Come on. How can you define humans in some other way? This is for the students to think even more harder.
So, while you're waiting, consider this question. What is important? So, is it how we look like? Is it what we eat? What if we start photosynthesizing? What if we genetically change ourselves so we could start using the sunlight as flowers and trees? Will we still be humans or not? Does it matter how well we count and read? The fact that we play games? Or how we make friends? Or how we choose to change the world? Or how we choose to live and change ourselves. So, what is important? What does it mean to be human for you? You see how our exploration of space comes right back to you. So, and of course you may wonder what other questions may intelligent living beings ask. It looks like we would assume that many of them may be interested in where did we come from? And what do we share with other living creatures? If there are living creatures in the universe, living on other planets, is there something that we share other than the laws of physics of the universe, or maybe some very basic chemistry, because we're made out of the most abundant chemical elements in the universe. We're mostly made out of hydrogen, carbon, nitrogen, and oxygen. Just 4 chemicals in the periodic table make about 97% of our body. And we may assume that probably other living creatures share at least some of those elements, probably most of them. What do we share with other intelligent creatures? Will they think the same way we do, or very differently? How about keeping our planet healthy, whatever our planet is, and whatever health means for our planet, right? How do we ensure that we do not go extinct? By changing our planet, by our own stupidity, by wars, by pandemic? How do we choose to live our life? Be it the life of an individual or a life of a human civilization? What is important to us? How do we build the future, our own future and the future of our civilization? And why do all intelligent creatures ask questions? This is actually maybe one of the most important things. You probably cannot be considered intelligent unless you ask questions and try to resolve them. And all science is built on questions. It is the base of all sciences. So, before we end this class, I want to ask you to please continue asking questions. This is the most important thing you can do to still stay intelligent, right? So, this is something for you to think over the summer. Decide how you would explain who you are to an alien. And remember, they may receive this message thousands of years from now. Together with your friends, come up with a page of questions. Exercise your questioning skills about other civilizations. And then try to think of some ways to resolve them. And remember, nobody will tell you whether you're right or wrong yet. We don't know yet, but you may give it a try. Maybe you will be the first one who will find some good approach. And craft a message to an extraterrestrial and decide on the best way to send it. Remember, they can live in very different planetary conditions. They might be colder, hotter, toxic for us, and so on. So, and if you want to learn more, right now the Blue Marble Space Institute of Science runs the astrobiology studies for kids. It's a free summer program led by our summer intern students who are starting to learn astrobiology in college. And they invite people to come and talk to them about astrobiology. And we also run a program at the Art of Inquiry for children from all over the globe. And the classes, some classes are taught specifically for kids in India, in English and Hindi, whatever you prefer, by 2 of our interns, Kashish Gupta and Simran Kaur. So there are no classes in summer, but we will restart again in September. So with that, I am open for the questions.
That was a wonderful presentation. I want to thank you, Dr. Julia, for the presentation. And Bhavya was saying regarding the question you had asked about the humans, that humans is a person who can modify the environment, because neither a cat nor a squirrel can modify the environment.
Well, in fact, they do modify it a little bit, right? the squirrels, they actually dig holes, they put some nuts there, they do modify it a little bit, not to the extent we humans do, right? They don't change the whole planet, but the living organisms that did modify a planet are bacteria. Thanks to bacteria, our planet switched from having no oxygen to a planet that has an oxygen-rich atmosphere. So some living organisms actually can change the planet a lot. Think of the trees. There was no soil on land. It was just rock and dry mud and sand until the first plants made it to the land and created the soil and completely changed the way the planet looks like. And they don't even have anything like a brain, right? So the living organisms can change the planet quite a lot.
Yes. And ma'am, if you can stop sharing your slides.
Yes, of course.
Yeah.
So,
And we had one more question in the beginning, and they were asking something related to, yes, how do astronauts drink water in space by Azan?
sorry, could you repeat again?
How do astronauts drink water in space?
How do astronauts drink water in space? Well, sometimes it doesn't happen, in the best way. So they have special packages with water, and they can squeeze them through the straw into their mouth. Now, I know one astronaut who was very happy to be on the International Space Station. It was his first day, and he thought that, well, I'm so well prepared. I'm going to drink my juice now, and all my crew members will see that I know how to do it. So he had this blueberry juice package, and he was squeezing it, and since he was looking at his friends, he didn't fully put the straw into his mouth. So the bubble of blueberry juice, grew out of that straw, left the package, and began to flow around until it actually ended up hitting the pilot of the spacecraft. And they had the blueberry juice all over. Yes. It takes some skill.
Yeah, definitely. So those kind of instances can also happen. Yes. So Bhavya is asking, any experience you have in space? So
I never went to space myself, but for many years I worked as an International Space Station astronaut instructor, preparing the first expeditions to the International Space Station.
Yes. So if you have any incidents you can share to the students, like one of the incidents the astronauts you have trained, if they might have shared with you, just like this one you shared with us.
Sure. Well, we had one astronaut who was telling us, why are you preparing us for all these mishap scenarios? It's not going to happen, it's not going to be that bad, that everything will go in an expected way, until he actually went up to the orbit, and he sent us a letter in a few days. Thank you so much that you trained me this well. I never expected what's going to happen, and it's happening all the time. New things are happening all the time. And when you are living in a new environment, in space, everything is changing. You start hearing differently. You start seeing differently. While you're here on Earth, you have gravity working, pushing everything down, pushing all the liquids in your body down. Your heart needs to pump the blood up. Your skeleton needs to keep you upright. However, when you're in microgravity, it doesn't work this way. So all the fluids that you have end up in your face that usually go down. So your face looks puffy. Your nose feels like as it's, full, congested. Same with your ears, and your vision becomes a bit blurry. And your heart begins to shrink because it doesn't have to work that hard. And our body works on the principle, use it or lose it. So you start losing your heart and you don't need your skeleton anymore. So you start losing the calcium from your bones. So being in space in microgravity is actually not very good for your health. It's dangerous, and doctors need to monitor you all the time, and you need to exercise all the time for many hours a day to stay healthy.
Yes. And they're also asking, how do you train them?
How did I train them? So there was a group of people. I wasn't the only one, of course, to train the astronauts. But the astronauts have to learn about how the space station works. And that was one of my jobs, to first explain to them in general, that's how our space station looks like. These are the modules that are connected to each other. This is how you walk through the modules. This is what you can expect to find in each module. And we had a mock-up on the ground so they could actually get there, open all the doors, close all the doors, all the drawers, touch everything, and so on. And then we would teach them how to control the space station. And that was actually my responsibility, to teach the astronauts how to rotate the space station. And you need to rotate the space station for many reasons. One of them is that you have the solar arrays on the space station that generate electrical energy, and those electrical energy have to see the sun. And the space station goes around the Earth, so you have to adjust there a little bit. But also there are things that happen sometimes. For example, when two spacecrafts are docking, one of them can hit the space station and the space station can start rotating. And it's not good because you want to keep all your antennas actually looking at Earth and not at some random places. You want your star sensors that show you where each star is and help you to understand where you are in space also start rotating. So this is one of the things I was helping them with. And we had lots and lots of exercises on computer simulated games where they would learn how to control the station.
Yes. And Sirat is asking, do aliens exist, and are they smarter than a normal human?
So, first of all, define smarter. I don't know how would you compare a human being to some other creatures. Smarter in what sense? Well, the dogs are definitely smarter than us in terms of smelling and recognizing smells, right? Dolphins process the information about 10 times faster than we do, and exchange information faster than we do. So we really need to define first what we understand under intelligence, right? Then whether there are aliens or not, I don't know. And one of the reasons we don't know is because we ourselves are a very new civilization. If you think about it, we have developed radio equipment just about a century ago. Even if there are any aliens out there that don't know about us, because we started sending the signals just a century ago. And many planets that may be Earth-like planets are tens to hundreds to thousands of light years away. Imagine that there is a planet with some civilization 50 light years away. It means it takes light 50 years just to get there. radio signals travel with the same speed. Imagine that we today send a signal to some planet that we think may have some civilization. It will take 50 years to get there. It will take them maybe 30 years to process our signal and understand what we're trying to say. 50 years back, and then us trying to figure it out. So a century and a half just to exchange the first signals, right? We're not there yet. We're just a baby civilization in technological sense. And this said, it depends if you want to consider how advanced other civilizations are. It depends on whether they started earlier, whether they had more time to evolve, whether they had less time to evolve, what kind of star are they orbiting, what were their conditions, did they have many mass extinctions on their planet and had to restart lower? So did they have any wars, or did they have, what was their history? We don't know. So even if there are other civilizations, we really cannot say yet.
Yes. It turns out there are so many more factors when we talk about, first of all, the smartness and also whether aliens exist or not. There is a question by Bhavya, which is it true that 1 month of Earth is same as 1 day of space?
I don't remember the exact timing, but I do know that you age faster in space than on Earth for many reasons. As I said, it's not healthy for your body. You are also always bombarded by pretty deadly cosmic rays that make your body age faster.
Yes. So students, if you have more questions, you can type it now. And I think we had one more question, which was, my system is just acting up. Give me 1 minute. Yeah. Yes, one question which we could not take earlier was related to the Black Sea. So they're asking, why is the color of Black Sea black? Sahil.
Why is the color of Black Sea black? I don't know. Well, probably it's dark. I have to compare that to other seas. Maybe.
Okay. So students, let's see if you have any more questions, which is related to either the International Space Station or life beyond Earth, life here on Earth, or the signals that we need. We're going to just wait for a minute or two. Yes, there was a question. Is there any possibility of life on Jupiter's moon?
This is a good question. So NASA is going to send a probe to one of the moons of Jupiter, Europa. And Europa is quite an interesting place. So it is an icy moon. And we think that there is a high probability that under the thick crust of ice, there is an ocean under that ice. And we do know that there are so many living creatures here on Earth that can live under ice in the ocean, that maybe there is also something there. So NASA is thinking about actually drilling through the ice and putting a robotic camera through that hole to send it there and check whether there are any living creatures living on Europa.
Yes. And one of the last questions we are going to take is again by Bhavya, who is asking how to use space station.
How do you do what, space station?
How do somebody uses space station?
Or how do we use space station? Or there are so many different ways we use the space station. Well, first of all, we observe how do people live on the space station. And every day we get more and more data on how to make the life of humans in space more comfortable. we collect the medical data and come up with new medical devices that first help the astronauts and then help the people on Earth. We do run lots of experiments, chemical experiments, physical experiments, biological experiments, and we learn so much about the life on Earth and what can we do if we decide to build planetary bases elsewhere and expand and actually become a seafaring civilization.
Yes. And that is such an exciting possibility. And I think even certainly it can happen in just a few years. So I want to thank all the students who are joining us for the day 2 of Alien Week 2022. And I want to thank Dr. Julia for making her time and being present and telling all about these different things. And my favorite was the images of Voyager and how we define the images and so much more. So thank you once again, Dr. Julia, for joining us. And I hope students had a fun session learning all about life with you.
Thank you so much. And again, thank you for organizing this wonderful event. And I want to thank all the students who came and who asked these wonderful questions. Stay curious.
Yes, thank you.
Bye.
Bye-bye. Have a great day ahead.
floating till